Numpy stands for numerical Python, and it's a Python extension module, and it's not a programming language on its own. So it provides fast and efficient operations on arrays of homogeneous data. That all I can say. The reason people wrote a specific implementation, packaged it, is because faster operations. Numpy is written in Python. Python is a language developed in C plus Python, and it's really helpful when you use Python. Python is generally blamed for being very slow when it compared to Java or C. I mean, writing, executing is very good, but runtime is much slower than Java and other such applications. So NumPy is a way to accelerate such operations, both algorithmically and mathematically. Efficient implementation as well as efficient programming. That's why we use NumPy if you have to make it anything faster. Again, NumPy can only do numerical calculations, not anything more. As we go forward, we'll look at it. So the first part in NumPy, okay, we'll look at Python practice. Just create a new Python. I'll name it as NumPy practice. You can continue in the same file, or you can. The way to import is import NumPy as NP. The reason why you use as NP, you can just import it. When you import, every time you have to use this package, you have to say NumPy. Instead of it, people say NP. And whenever you want to refer NumPy, you can just say NP. And that makes your life easier. You can have another shortcut also, but it's a very popular standard. It's not a standard, it became a standard, I can say. Right. Okay, get ready. We'll start. The first one is we'll look at first of all the object, the fundamental object in NumPy array. What is the fundamental object? Is nothing but ND array or n-dimensional array, right? So how can you initialize it? You can just use np.array, put parentheses and pass the numbers inside it. Here we are, for the time sake, we are using only one-dimensional array for now, but we can initialize multi-dimensional arrays also later. I'll just show you sample nd is equal to np.array parenthesis. Inside parenthesis, you have to pass a list, otherwise it won't take it directly. And you can do sample, execute, I'll show you. Right? You can also look at, okay, this becomes, can also look at type of a certain object. It will tell you numpy.nd array. If you have to give a two-dimensional array, what do you mean by two-dimensional array? Rows and columns. What is three-dimensional array? Rows, columns, and there's one more third dimension, depth, x, y, z. Right? So sample two-dimensional array, you can just write it as np.array and parenthesis, first bracket, and inside first bracket you can put 1, 2, and again you can pass one more 3, 4. So This is row 1, this is row 2, and each row has 2 columns, and entire thing in an array. I can execute it. Now we can print it out, sample 2 dimension. If you want to know how many dimensions this is, right, you can look at dot shape is one way to understand. What do you mean by shape? How many rows and how many columns. If you give a 3-dimensional array, it will give you 3 dimensions. So I'll just show you here. I've been showing. Dot shape is a function which will tell you shape of the array. I have a 3-dimensional array also here. Okay, and just putting it. So remember to put the brackets properly. Of course, in real you don't initialize in this format. np.array. This is 1, 2, 3, 3, 4, 5, and 4, 3, 6. All this first rows, then columns, then height. So how many dimensions are there? That many square brackets should be there on either side. 3D dot shape, that will give you one dimension on the height front. Rows and columns are 3. Three rows, 3 columns. Try it out, everyone. How come? Oh, I think it was being initialized as tuple. Can you look at the square brackets initialized, Sunil? And did you use this function np.array? If you miss this square bracket, something, okay. Can you share the screen if possible? Okay, you have to use np.array in front of it. Otherwise, Python will default take it as tuple. This is a must. np.array is a must. I think you missed that, and Python is reading it as tuple. Yeah. Perfect. Right. And you could have easily figured out if you type, look at the type, it would throw it as tuple. Anyways, now then shape, there is one more thing called size. You can look at size dimension also. 3D dot size, it generally prints you how many numbers are there inside your if you can look at sample 3D size, 9 elements are there. 9 elements are possible. I mean, there's no right. You can also look at dimensions. Dimensions are nothing but number of faces or number of axes, whereas your size gives you rows, columns, and how many are there in each rows, how many rows columns are there. Dimensions will just tell you how many dimensions are there. If you look at ending, what is 2 means here? there are rows and there are columns, 2 dimensions. And sample, if you look at 3 dimension, it will give you 3. Dot ending gives you the dimensions, right? And a type we have seen, size we have seen, right? Just try all this for yourself by creating some arrays on yourself, and try size, shape, and dimensions. Try to create more dimension, 4 dimensional also. You'll get to know. I'll give you 5 minutes time. Please practice. All right. I hope you guys gave it a try, everyone. Right. Now we'll look at the other angles of making an NumPy array, most frequent ones when you do it. So one way to create is using np.zeros and np.ones by giving shape and dtype also, and then you can get an n-dimensional array instead of creating matrix, putting zeros, 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 and all. This is an automated way of doing it. Show you. X is equal to np dot zeros, and you have to mention size. Size is equal to, that is nothing but your dimension, sorry, not size, shape. That's your shape. You have to pass a tuple here, 3. Dtype is not mandatory, but you can do it. Okay, where did we go wrong? Okay, one more bracket is missing. Okay, spelling zeros, spelling mistake. So we got it. And I can specify the type is equal to int also, I think. And it will initialize every element as an int. You can put more dimensions also, 2, 3, 3. And that will show you 2 phases, first phase, second phase. In each phase, there are 3 rows and 3 columns. And similar function is like np.ones. When you need to default initialize, and you can get np.ones. Let me put 3, 3, 3. Will show you 3, 3, 3. And you can put multiple dimensions also, another 3. It will create a very huge thing. So there are 4 dimensions in total. So you can create all these dimensions manually with NumPy arrays. These are very important when you go into data and want to initialize arrays and then later on modify them. Right? And the next one is, this is very important, accessing or indexing an element or NumPy array. Before accessing, we will look at arange. Arange is nothing but range function which has given us in Python default. Basic, the same thing, the same implementation in your NumPy. So I can take and I can just run it here. So what does it do? from 50 to 100, it generates all the numbers. The same, you can put a step here. If you put a step, every second number is selected. Starting number is included, ending number is excluded. Now, how do you index it? X of 0, obviously 50, right? X of 1 and Python basic indexing. So X of -1 starts from reverse, minus 98. The same indexing in the case of lists is used in arrays also. So X of 0 to 10, first 9 numbers. 9th on, 10th is not included, right? So the same indexing which we have learned in lists, and the same way the slicing is implemented in lists, the same way it is done in Numpy arrays also. You can access in multiple ways: skip, start, stop, step, and all. And specific index to end, specific index to start, and all. Here is a class task for you guys, because you are already done with indexing. I'm giving a class task directly to you. Create an array of 10 numbers, slice it, print 5, 5th, 7th, 9th element from the start. Do it with positive indexing, do it with negative indexing. Task is in front of you, try it out. Got the solution, guys? How many of you got tried it? Yeah. Okay, Parnika, one more thing is NumPy arrays are very, very optimized for matrix operations and algebraic operations. So ideally, Python lists are generally a data type which is like multi-purpose, created by the creator of that language, Python, right? But NumPy arrays, though they look very similar, the reason we have to create a separate data type is the way it is stored underneath, and the way matrix operations are done on NumPy arrays are pretty different. So that makes it all the difference. So if you try to store a matrix as a set of lists and multiply two matrices in the list format, and take numpy arrays, two numpy arrays, and multiply them, then you'll understand the difference. Numpy arrays are like pretty faster. Yeah. So, I mean, if you go into machine learning, everything is about matrix multiplications or algebraic equation solving, optimizing, and all right. So, NumPy allows us to run these things very fast. In fact, sklearn, one of the very popular machine learning library, is built on top of NumPy only. Pandas is also built on top of NumPy. Yeah. Right, and the next part is like making a copy of arrays. Of course, now Python 3.9 has come up with a deep copy by default. Uh, Earlier, we used to have this problem, right? So what happens is like, I hope you guys understand pass by reference and pass by value. Any comp science students here? Just give me a moment, I'm explaining it. So this is one important concept when we try to copy, especially in Python and certain data types, right? For example, okay, give me a moment. Let's say A is equal to, you put it as 2, 3, and 5. And you do B is equal to A, right? And then do b dot append. I'm talking about lists only mostly. B dot append, you take one more element 7. Now, do you think B changes or A changes or both change? Try to print B and try to print A both. So if B is printed, you think that it should be 2, 3, 5, 7. Very true. But if you print A, A is also 2, 3, 5, not 2, 3, 5. It will be 2, 3, 5, 7. You think that when you did B dot append 7, it only affects B, doesn't affect A, right? So the way this works, B is equal to A, works is in two ways. One is pass by value, and the second thing is pass by reference. I'll explain you each of them. What is pass by value? When pass by value is done, if that object data type is, this kind of operation is written such that pass by value is done. So all the contents in A will be copied to another memory, right? There will be two memories. This will be A memory, and all the contents here will be copied to B, and this will be B memory. So any changes in B will not reflect in A if two memories are created, right? When we did B equal to A. So when you do pass by value, what happens is like extra memory is created for B, and whatever changes in B are not reflected in A, because they're two completely different memories. But languages, they're written to optimize optimize memory usage. When you do B is equal to A, what happens is that there is a single memory storage and A is pointing to it. And when you do B is equal to A, B also gets pointed to this. And when you do B dot append 7, you think that you are only changing B, but the memory is the same thing, and it gets changed here. And if it gets changed, even A is getting changed. So underlying, there's only one memory slot which is saving this data, and multiple variables are referencing to it. Right? So Python is by default pass by reference, right? In case you don't want B equal to A, both memories differently, then you have to do something called as deep copy instead of just doing B is equal to A. When you do deep copy, then this is implemented. If you just do b equal to a, this is implemented. This is passed by reference because you are just passing a reference to b. This is passed by value because you are actually passing the entire content and new memory is being created. Clear, guys? You can try it out also. Let me do it for you. A is equal to mp dot array and 2, 3, 4. Okay. Can I do append here? Let me do b is equal to a. Now b is equal to b into 2. Let me print a b multiplied. Let me print a. Okay. So when we did b equal to a, this is, yeah, recently that's what Python has changed from pass by reference to pass by value. So here what I did b is equal to a. I went and changed b, right? But b only changed, a didn't change. That means it's passed by value which is happening here. Earlier, long back, it used to be passed by reference, but now it's passed by value only happening. And unfortunately, you have to keep checking in Numpy or in less what's happening. Sometimes Python does pass by reference, sometimes it does pass by value. So be careful, or at least remember what is happening. Let me check for lists equal to 3, 4. Okay, let me put a equal to b equal to a star 2 a. Okay, it's changed. 2 times it became a. Now print b. Okay, b didn't change. So it has changed to pass by value completely. That's what deep copy has lost its relevance now. Earlier we had to use a deep copy so that this is manipulated. Right? So now we understand, right? It is passed by value happening in Python, both in lists and both in arrays. So I can skip this deep copy part. Right? And let's look at manipulating the elements in NumPy array. How do you manipulate it? First thing of manipulation is a reshape. That means you want to take the shape size of the NumPy array. For example, I'm creating a is equal to numpy a dot shape. It's like 3 rows and 2 columns. Maybe I want it to reshape a dot reshape to. Let me look at you have to give the dimensions separately. It's 3, 2. I can make it into 2, 3. We'll print it out for you. By the way, a doesn't change. Earlier a was like this only. Because as I told you, when you do reshape or some functions, you have to assign it back. Now you get it, right? A is equal to, let me print a. Originally it was like 3 rows, 2 columns. Now that's what we showed. I reshaped into 2 rows, 3 columns. Right? As long as your dimensions are the same, number of elements are the same. So 2 into 3, 6, 2 into 3, 6 matches. You will get the NumPy array. Reshape will happen. That's one way to modify your array. And there is one more thing called reshape -1, 1. it changes the direction. I'll show you this one also. This one you will not find it relevant now, but I'll tell you when you go to machine learning, it makes a lot of impact. Reshape -1, 1 print a. Now it's like one dimension. So earlier it is one dimension. That means look at the shape of a. A dot shape 3 comma 1, right? Now do this and do. Now do a dot shape. It still shows you 3 comma 1, but the way it's printing out is different. Each one in each row. Earlier it was each one in each column. Now each one is in each row. There is a difference to it. Once we go to machine learning, you'll understand it. Right? Just try reshape. Okay, or else let me do one more operation. There's also resize operation. You can explore it. The next part is transpose. I hope you understand what is transpose. Transpose is like making rows into columns, columns into rows. So if we will take one n-dimensional array, okay, I don't need to sample 2-dimension dot capital T will give you transpose. What is actual sample? Originally 1 2 3 4. Now it became 1 3 2 4. Making rows as columns is called transposing. One more operation in your algebra. Right? And np dot round is nothing but it rounds your decimals to the nearest integer. You can put decimals is equal to and you get all the rounded values for the array. And there's one interesting application here. If you take integers and use np dot round and pass decimals as negative number, then your integer will be rounded to nearest 100th number. Or sorry, we put 2, so nearest 10th digit, 10 power 2. That means 89 will get 200, 456 will get to 500, 7899 will become 7900, 12 becomes 0, 50 becomes also 0. So how many decimals you put, that many tenths digit number it goes to and it gets rounded. One interesting application when you wanted to round the numbers, even the integers. To simplify,